pretty much from day one, I wanted to make my own APL because I found it really interesting that unlike Python, there's multiple implementations, right? There's C Python and PyPy and whatever, except for some internal things. So you all do the same thing. They all have the same functions. And APL is different because every dialect, every implementation has its own features, right? And that was really interesting to me.
Welcome to episode 88 of ArrayCast. I'm your host, Connor, and today with us we have three panelists and a special guest who we will get to introducing in a very short period of time because we have no announcements today. But first, we're going to go around and do brief introductions. We'll start with Bob, then go to Adam, and finish with Marshall.
I'm Bob Terrio. I am fresh off Iverson College, as you've probably heard, and I am a J enthusiast.
I'm Adam Botsevsky. I'm also fresh off Iverson College, which you've probably also heard, and I do APL for a living.
I'm Marshall Lockbaum. I know you've missed me desperately in the past 4 weeks. I've worked with JN Dialog in the past. I work with BQN and Singeli now, which are my languages.
And as mentioned before, my name is Connor. I am a massive array language enthusiast fan and super excited about our guest and our conversation today because we have alluded to this language and the author of this language several times, and we're having her on. Her name is Madeline Vergani, and she is the author of tinyapl, is I believe the correct pronunciation of the language. I think we mentioned this language at the end of 2 episodes ago, maybe. It might have been 86 or 85, and or actually it wasn't so much on this podcast. I'm getting my podcasts confused. It was on Tacit Talk when I was interviewing Adam on episode 4. I think there was a solid 20 or 30 minutes that we ended up turning a 90-minute episode into a 2-hour episode because Adam mentioned tinyapl and how it was going to get the modifier trains from the J language, which I was like, are you kidding me? First of all, there's another APL out there. I think tinyapl was on my radar, but I had no idea about the combinators that were coming in tinyapl. I'm going to stop talking, throw it over to Madeline. Maybe you can introduce yourselves, tell us your story and path to the array languages, and then we're going to dive into everything tinyapl, and we're going to talk about this new APL that has, is breaking news. Another APL is out there.
Hi, my name is Madeline, and I got into array languages sometime during the pandemic. I'm not sure how. My first time I found out about them was when I was quite younger. I was maybe like 12, and I was using the Snap programming language, which is a block-based programming language, kind of like Scratch, but it's better in my opinion because it has first-class functions and first-class lists and a lot of other useful features. And one of the things is that a standard library, and inside the standard library there's a module called the APL primitives, and inside it there are some functions that had like a weird Unicode glyph in yellow and then an English name of what they do. But I didn't really think much about that for when I found them. I just kept it in the back of my mind, thought it's interesting, maybe I'll look about it later. Then we jump a few years later, now it's during the pandemic again, and I was looking through Unicode glyphs, as one does, I guess. And so I saw in the Miscellaneous Technical there was a whole block about some glyphs that were called APL functional symbol and then a name. So I remembered about the other time I saw about APL, I thought, are they the same thing? So I looked it up on Wikipedia, and it wasn't really, it showed me a bit about array programming, but it wasn't really much informative. So I went to YouTube and I found Connor's videos, and my first experience with APL and with array programming language in general was Tacit. So I learned Tacit programming before I learned defense, I think. So then I downloaded the RIDE. I started playing with it. I never actually followed like a tutorial or something. Most of it was I learned through experience. And pretty much from day one, I wanted to make my own APL because I found it really interesting that unlike Python, there's multiple implementations, right? There's C Python and PyPy and whatever, except for some internal things. So you all do the same thing. They all have the same functions. And APL is different because every dialect, every implementation has its own features, right? And that was really interesting to me. So I thought I want to make my own. And I had a draft of a very big project that I think I called Maple for like M APL, so Redis Maple for modern APL. It wasn't really modern. It was just full of features that didn't fit the array paradigm. Like, I never got to implementing it because I didn't know how to parse it was the main problem. So this project didn't go anywhere. But then this is August last year, and I started thinking of doing an array programming language again. This time I wanted to start with something I knew I could do, and that was like making a library for a normal language that had the APL-like arrays. And I chose Haskell to do that because I had recently learned it and I found it really interesting. And then I also decided to write a series of blog posts about the development. Well, mostly just because I just made the blog, so I wanted to put some stuff inside it. But also because I thought that writing about the things I was doing would help me reason about the things I'm doing, and like I had to explain what I'm doing, right? So it had to make sense to myself. Yeah, so I started doing that. I think the first blog post was just about implementing arrays, then I implemented functions, I implemented some primitives, and then I tried actually doing the parsing again because I had asked around and I was pointed to the Bundager parsing paper. And I kind of understood it, but not completely. So I had an implementation of it. I released it publicly for people to try around and find mistakes and whatever. And then I abandoned it for like from November to March. I didn't do anything because I couldn't figure out some bits of parsing. I can't remember what now, but something didn't work, and I lost motivation because of this. And also, I wasn't really feeling that well mentally at the time, so there were some other issues. But eventually, I got back my motivation, so I started again. I figured out the parser, and from then, I just kept implementing primitives and features, and it's coming off real strong. And especially in the last months or so, like all of August, I implemented over 45 primitives. So I mean, a lot of them were easy, but some of them were not. And yeah, it was really nice to see that now tinyapl is an unusable language. Until August, it didn't have catenate, right? It's just very fundamental primitive. You just couldn't join to arrays. Yeah, now you can, and there's a transpose and outer product and all stuff like that. So you can do a lot of things now. Because I learned Acid so early in my APL path, I guess, I had a strong focus on combinators and eventually trains. Combinators were one of the first thing I added. I think very early in the design, I planned for a combinator. It's called Mirror, which I didn't invent myself, but I came up with it independently. And basically, it calls one function with both arguments and the same function with both arguments but swapped. And then it was another function with the two results. It's useful sometimes when you want to like pre-process both arguments in a way that depends on both of the arguments. So you like right, the top, whatever, and then you put it as right operand to mirror. Later, I came up with even more combinators. These are left fork and right fork. Maybe I'll talk about them later. And then I also added trains recently, which are very interesting, I think, and I can talk about them later.
All right, I already have so many questions. So, I mean, we'll start with mirror. I mean, we're gonna dive right into it because you've like baited me with all your combinator talk of left fork, right fork, mirror. So I recall finding my way to the tinyapl.rubenberg.com/doc/info/combinators.
Yep.
So is the mirror that you just mentioned, is it there? Or because this is kind of a comparison page to the Weewa has a combinators page with little diagrams in place as well. Does this list all of them, or is there a better place to go to look at the full set of combinators?
No, that's all of them except for leftdex and ident, which I implemented like this morning, or even this afternoon, I can't remember. So yeah, apart from those two, they're all there, yes. The mirror is the third to last. It's the minus with the dots above.
Oh, okay. So it's a minus sign with the double diaresis, and it's known as the parrot.
Yes.
Interesting. And this is the P combinator, and so you're saying it's basically a dyadic fork.
Yeah, it's the fork G commute F G basically.
Yeah. So it's kind of actually a combination between the psi combinator, aka what APL and BQN call over, and the dyadic fork. So each of the tines is the same function, and you just swap them.
Well, it's not surely not over.
Well, yeah, it's like over, but
Because over preprocesses each argument separately. This one takes both
Well,
arguments.
it's a bit like over, except the missing argument is also included.
Yeah, no, that's true. Yeah, it's like over, but the preprocessing function gets the other argument as left argument.
Yeah. The reason I say it's like over is because in over, aka the psi combinator, you're applying the unary function twice, and in this case, you're applying the function g twice just to.
Yeah, and actually you can easily get over because you do F mirror parentheses G atop right, and then
yes.
that's either over
Yeah.
if it's right or left, I'm not sure.
If G is a function that takes a left argument but doesn't actually use it, then it's equivalent to over.
Yeah.
Yes.
Is this something that came up, or are you just doing this for kicks because you really like the dyadic fork and one time you needed to swap the arguments? Because this like it makes sense when you walk through it, but off the top of my head, I can't think of.
I've got a few instances on Apple Cart that need it.
Was there a motivating case, Madeline?
Yes, when I was doing the APL competition or challenge, can't remember what it was called last year, there was one challenge where you had to process only the part of the array that you got two arrays, two vectors, and you had to only look at the length of the shortest ones for both, right? So to cut one to the length of the shortest one. And I wanted to have mirror there because what I wanted to do was like a minimum over length take right. And then for the other one, you just reshape the same thing but with left. And in the middle, you have the actual function that solves challenge. I think I actually submitted a version that was an operator and it had mirror defined as a DOP inside. So I had the function and then the DOP and then minimum over tally take right. I wanted a useful operation that you needed every time you want to process one of the argument, but based on something that depends on both. I use it also to promote or demote to the correct rank when the two arrays have different rank. And I think I couldn't come up with any other use though. So it's cutting to the length and cutting to the rank basically.
So yeah, there's a bunch of motivating use cases here.
Another one would be the symmetric difference of sets where you want all the elements that are in exactly one of the two sets. So you take the difference like A minus B.
Oh yeah.
And then concatenate that to B minus A.
Interesting, yeah. And so I guess, well, my next question is the left and right forks, but maybe we'll pause there because I've totally, like I said, I got, what is it, nerd sniped or baited into asking these questions. Maybe we should take a step back and talk at a high level about the differences because if you go, we'll make sure that we link this Combinator's documentation page in the show notes, obviously. But up until I think the Bluebird, or the B combinator, this looks, I think, similar or if not identical to Dialog APL, but then you hit the Q, which is a different combinator, and then there's a slight differences, and then it looks like you've even borrowed the symbols from BQN for monadic and dyadic before and after. So maybe even outside the combinator space, maybe let's summarize or have you summarize the sort of major differences between Dialog APL and ideas that you potentially borrowed from the other array languages like BQN, and we'll go from there.
Well, the main difference is definitely that parsing tinyapl is context free. This for example, in Dialog, if I write A space B space C, you can parse in a lot of different ways. Like if there are other ways, it parses a strand, but if B is a function, it's like dyad application. If F and A and B are both functions, it's two mod applications. To resolve that, basically you have to, while parsing, check, or at least while binding and making a syntax tree, you have to look at the names that are defined and change the way you parse based on that. I didn't really like that. I thought it was too complex. And BQN already doesn't do this. They have basically a casing convention, a naming convention for the names of functions and arrays, etc. So an array is lowercase, first letter is lowercase. Function, first letter is uppercase. An adverb, first letter is an underscore, and in a conjunction, the first letter and last letter are both underscores. That's exactly the same as in BQN, except that the four classes are completely distinct. Like I can have a lowercase array and an a uppercase function that are unrelated. And in BQN you can't because they like refer to the same variable but in different contexts, I guess. Yeah, so I took that and I extended that to other constructs. For example, defense, you write the same way you do in dialogue, but if you want to write the adverb, I guess you can call it, you have to prefix the opening brace with an underscore. And if you want to write a deconjunction, you prefix and suffix with an underscore. This is so that binding is easier. You can theoretically find out whether it's a modifier or not by looking inside the code and seeing if it refers to like the alpha, etc. But I found that to be too complex. I want the code to be parsable by the reader at first glance, right? I don't want you to look inside the defn and see, okay, it's an adverb. So I go back and redo all my mind parsing, knowing that's an adverb, right? I want it to be clear up front. I also don't have stranding. I prefer array notation to that. Recently, I've also added ties, I call tie syntax, which is basically the joiner thing from BQN. I also have first-class functions and operate modifiers. So they're useful sometimes. And also trains are not invisible like they are in other array languages. They use a specific syntax that you can see that it means a train. I also have modifier trains from J. And yeah, I think that's the main. Oh, I don't have like last axis versions of the replicate or reduce or rotate, etc. I only have the first axis versions. I think that's the main. Those are the main differences.
Interesting. So you borrowed the casing from BQN minus the fact that you can overload them to, whereas BQN doesn't allow that. Did you borrow the syntax for forks? Because I think I saw that, if I'm not mistaken. Is it just a coincidence, or did you borrow that from Cap? Because I see you've used the same glyphs for that.
It's inspired by Cap, but in Cap it's a like syntax thing. Whereas in tinyapl there are normal operators, so the binding strategy is different. The fork operators are not really nice to use because most of the time you want like a long function, I guess, in the middle line or the right lines, and like I don't know, another composition, and you can't do that because it parses wrong. So you have to do parentheses, and that's why I introduced train syntax, which is nicer to do that, I think.
So you said that there's the prefix and suffix underscore. Does that mean that you don't have to use the double alpha and double omega? You can just use a single one, because you still need a way to disambiguate between I guess you call them operands instead of the like function arguments versus the array arguments.
No, you still use them, but in dialog, the way to know whether a defun is a function or an operator is that you look inside and you see if there is alpha alpha or omega omega, and in that case it becomes an operator, right?
Right.
You don't have to refer to them in tinyapl. Like maybe I want to write an adverb that ignores the operand, and I can do that without needing weird syntax like you do in dialog, where you write like omega diamond alpha alpha to make it an adverb, and the alpha alpha is ignored because omega returns, but it turns it into an adverb. You don't need to do that. You can just do underscore open brace omega close brace, and that becomes an adverb. Also, because of each name only has one class thing, you have to distinguish between function and array operands. Array operands use a double alpha and double omega, and function operands use a double underscore alpha and double underscore omega.
Okay, and last question, and then I'll throw it over to Marshall and Adam and Bob, because I feel like I'm just rapid firing. In Cap, because you don't have the 3 train, you end up with this, ability to compose unary functions and have it fall out naturally. But that's also because it does have the 2 train. Did you do away with all train programming? Well, obviously, you mentioned that you have modifier train, so probably not. But is it just that there's no 3 train and you still have the 2 train similar to dialog and BQN, or are there no 2 trains either?
No, there's both 3 trains and 2 trains, but they are explicit. Maybe I can talk about the trains work. Basically, instead of having invisible syntax, like you put 3 functions together or n functions together, you do like open white round parentheses, which is basically like parentheses, but the 2 ends are connected by a straight line. It's looks like a bit like a moon, a half moon. So it's like open moon, and then you put the function separated by diamonds, and then closed moon, and that's a train. And it has four advantages, I would say, over the syntax that all the other array languages use. The first one is an advantage just for me, which is much easier parsing. I tried to make invisible trains work. I couldn't figure it out. But that's not really an advantage to the user. The advantages to the user are, first of all, that modified trains are really easy, like both for me to implement them, but also to write them, because if you want to make a train that returns an adverb, you just do underscore and an open moon, just like in every other, like just like for a defense. If you want to make a train that returns a conjunction, you do underscore open moon, close moon, underscore, of course. The third advantage is what I call any position in any class in any position. So basically, in dialog, there are two types of forks. There's the FGH fork, which is like function, function, function. It's the normal fork. And there's also an AGH fork, which is array function function. And you can interpret it two ways. The first way is to think that the array is an implicit operand to constant, so like tilde dots. So the train becomes a constant GH, and that's part of the normal fork. You can also think about it as the array being bounded to the function, so it becomes A bind G atop H. What you can't do, though, is an FGA train, right? So function, function, array. You'd expect it to just bind the argument the other way, but it doesn't work because FGA is parsed as two model applications, right? So F called on, G called on A. It's not it doesn't return a function, it returns an array. With my syntax, you can do that, right? If I write open moon, F, diamond, G, diamond, A, closed moon, that's parsed as a normal train because it's inside train syntax. So you can do like, no, if you want to subtract one from a list and then reverse it, you can write a train reverse minus one instead of having to write like one minus commute reverse or reverse minus one constant, something like that. The last advantage is nothing syntax. I call it nothing syntax because of a similar feature in BQN. In BQN, there's this nothing pseudo value, I guess you can call it, because you can't really put it in an array, etc. But if you pass it as a left argument to a function, it's called monetically. So if I do nothing -2, it returns -2. Like it ignores that the left argument is like nothing. And one of the things you can do with this nothing is put it in trains. If you want to write a long chain of tops in a fork in a train, you can't, because if you write like no reverse minus sign, that's parsed as a fork, not as a top and a top. So the way we can solve it is nothing. If I write reverse nothing minus sign, that's parsed as the sign, a fork, nothing minus sign, and a top with reverse. But because the left line of the fork is nothing, it's interpreted as a monad call. So in effect, it's the same way as you're doing reverse a top minus a top sign. And I don't have nothing as an actual like symbol, but because I have all the tines separated by diamonds, what I can do is just leave one tine empty, right? So I do diamond, diamond, and that's interpreted if it's left tine, of course, otherwise it's just a syntax error. But if it's left tine, it's interpreted as force the next function to be on a top, right? So like the reverse minus sign thing becomes reverse open moon, reverse diamond, diamond minus diamond sign, close moon. Some of these came up after I already made the syntax, but they were like, especially any class in any position was what convinced me that the explicit train syntax was actually useful and not just a easy parsing cop out, I guess.
If you, O'Connor was asking about what happens if you actually make what he would call a 2 or 3 train, meaning if you actually put two functions adjacent to each other, isolated context.
Yeah, that's an error.
And it's an error.
So, and to maybe make one more distinction clear, the APL problem that some people have with trains that it doesn't solve then is this odd even problem where like if you have a big long list of functions, the odd ones are treated differently from the even ones. So I guess that's something that the cap syntax is good for, and that Iverson's APL syntax and the tinyapl syntax they don't try to solve, at least.
Right. You still have the odd even. You could, I mean, what do you use as separators, diamonds, right? you could potentially have every other symbol being special, being different than diamond, left diamond, right diamond, whatever. That in order to show what the same way as the cap symbol is. It's also, I find it interesting that you find a better way, a different way of doing things, but then you keep the old way around, even though, I mean, I suppose you don't really have a user base or you don't really care about backwards compatibility at this point, right?
Well, it's mostly because sometimes if I want to do like reverse set of minus, I can write reverse set of minus. There's no point in using a train because it's longer, right? If it was implicit, it would be shorter. But because I have explicit train syntax, it ends up being like 2 characters longer, I think. And it's used as clutter, where you can just write reverse set of minus or whatever. So I keep both because depending on what you need, they are clearer in different contexts, right? So if you have long functions in the top, I think it's clear as a train. And also you need parentheses around the right operand, so it's also more cluttered. But if it's just simple function, I think a top is easier, and the same goes for fork.
Yeah, so there's this really good, in terms of understandability, or trying to get to understanding these combinators versus trains, which we'll link in the show notes, documentation page, which is the same link I said before, but instead of combinators, it's combinators_trains. And it has basically conversions between the two. And for a lot of them, the combinator version, aka not using the explicit train syntax that, has the two symbols that kind of look like moon, two crescents. A lot of them are shorter in the combinator form. But like you said, there might be use cases where you prefer one over the other. I noticed that you have on the combinator page, you've got symbols like for the, delta combinator, which is the before, I believe it's the dyadic before in BQN. You have both the symbol from BQN, which is like the little circle with the left line out of it, and then you also have the, hopefully coming in Dialog APL 20.0, jot underbar, which is, I think, the same thing, hopefully going to be coming, that's not existing there yet. But it is an extended dialogue, although I think we talked about that.
It's actually in Zyma APL is where it showed up, and then cap after that.
Right, and it is in cap as well. I didn't know it was in Zyma APL. So there is precedence for this. Is that just because you want to support, you're trying to one array language to rule them all? You want everyone to be comfortable coming from whatever array language they're coming from? Or what's the story behind having two symbols for that?
My before, monadic before doesn't do the same thing it does in like Zyma and Kappa. It's not a hook. And neither is after, like it is in cap. Monadic before does basically reverse function composition, so it's the clear combinator. It's basically G atop F, G compose F instead of F compose G. So the jot underbar and the left hook symbols you can use both, because if you want to write a monadic hook, you have to use the left hook symbol. Before doesn't work for that. But the dyadic meaning is the same in both cases, so it just happens to be the same, right? You can also see if you go to the Blueberry combinator, the normal function composition, there's 3 different combinations that do the same thing, and it's also in dialog, it happens the same thing. They are different when they become dyadic. The same for before and left hook, they become different when they're monadic. If there was like a competition for APL with the most combinators, I think I would win. By my count, I have like 11 or something like that. They're not all useful all the time, but sometimes it just comes up that you need that specific thing, and it's nice to have a combinator instead of a train, I think. I like combinators more than trains.
Yeah, this is super, super, super interesting. And I mean, we'll pause here if anyone else, Bob, Marshall, Adam, has questions before we pivot. Bob's got his hand up.
I've got my hand up because you've taken J's modifier trains, which I think are one of, at this point, the underused part, and you've incorporated them into tinyapl. And there's a lot of people in J who do not use them. I think it's just because they're not used to them. But you're putting them into the new language. How are you using the modifier trains?
Well, the main way I've used modifier trains is to do away with the like hyperators in NAS 2000. Like if I want to commute a conjunction, I either have to introduce a whole different class of types, so not an array, not a function, but not an adverb, but not a conjunction. It has to be like a hyper adverb or something. And with modifier trains, there's an easy way to do this. You just do a three train, dex, and then the conjunction and lev. And lev and dex are also from J. They are like the identity conjunction. So lev returns the left operand and dex returns the right operand. And I mostly use them for that. Sometimes I also use like the hook to modifier train, which is like it takes an adverb that applies an adverb and then passes it to a conjunction, and on the other side it leaves it unchanged. That's also been useful sometimes, but I admit I don't use them really often. I just think they're nice to have when you do need them. And also, because of my special syntax for trains, they're like a natural extension, right? There's no reason not to support them. So I just do.
Yeah, and I guess they're a bit of a toolkit when you're trying to take one combinator and making an adjustment to it without having lev or dex. You're really going to be working harder to try and do that same thing.
So once again, we will link this because it is really, kudos to the listener that is hanging on here for hopefully not dear life, but almost probably dear life. There's a third documentation page that the first one was /combinators. The second one was /combinators _trains. And the third one is just /trains. And this one has 1 trains, 2 trains, and 3 trains as partially described before with the, we'll call them crescent. Do they have an actual name that the Unicode kind of...
Unicode calls them wide parentheses, I think.
Wide parentheses. All right, we'll call them wide parentheses.
White, I think, is the color
Yeah,
white.
Oh, white parentheses. Interesting.
So I guess it's like an outline.
Yeah, that is interesting.
They're like blackboard bold, but for parentheses.
Oh, yeah.
Yeah, I found out later that there is like a better glyph for that, because the one I use is theoretically it should have both lines of the parentheses curved, whereas there is another one which is like Z notation something, which actually has one straight line and one curved line. In tinyapl 386, I use the straight line for the curved line symbol, but I think it's clear enough. I don't think I have to change that.
So in this documentation page, there are, you've got the _A representing what I assume is adverbs, _C_, which is what I assume is conjunctions. And then you've got different functions, FGH and X, Y, U. Is the color coding scheme... walk us through the color coding scheme, because I think I've kind of gotten it, but in some of them, especially in the 3 trains, you'll end up with _A, _B, _C, at which point I'm lost. I guess those are 3 different adverbs. I guess anyways, instead of me guessing, let's have you walk us through what the color coding and kind of notation is trying to represent here.
Yeah, well, in this page, there's 2 ways you can tell what class a name refers to. The first one is every class has its own casing convention, right? So you can tell what types things are just by looking at the name. So the first 3 train I see is XYZ when they're all lowercase, and that's a array train, right? But also there's color coding, so syntax highlighting, I guess. Arrays are red, functions are green, adverbs are blue, and conjunctions are yellow. In the interpreter, the colors are slightly different. I think I use I use colors in the same they're not the same actual hex code, but they're the same generic color as the one is in BQN. I just stole it from there.
Okay, let's walk through the first one of the 3 trains that has a U in it. So it's U _ in front of the white parentheses or crescents. Crescents shorter. We might call them crescents. So we've got the _ left crescent, and then _A for an adverb, diamond G, diamond H, and then end crescent. And this maps to not a 3 train, but a fork where so U is the array here. Is that correct?
No, it derives a monadic operator or adverb or one modifier. So what's inside the
Yeah, so
crescent?
U is an array, but
Yeah.
U is an array that's used as an operand.
It's kind of confusing. U and V can actually be functions too. It's just like they are the operands, but they're just there for explanation purposes. Like inside the train, you always have the correct name classes. Outside is just generic, but otherwise I have to duplicate, right? I have to do U underscore etc. Then new line F underscore is useless. So because they do the same thing, whether they are arrays or functions, I just use U and V as placeholders for both arrays and functions.
It's basically, imagine the underscore A was just another function F. So you get a normal FGH train. But F isn't quite defined yet. What we know about F is that F is derived from underscore A.
Right, right.
And the only thing we need to complete it, our knowledge about what's going to happen when we apply this, is to know what the operand to underscore A is.
Right.
So it's like there's an empty slot there. And once we fill that, then we got our complete FGH train.
So yeah, it's basically if you had this common pattern in my head, the obvious one would be like a reduce.
Yeah.
So if reduce was you had a reduction as your left function in a fork, but you didn't know what binary operation you wanted to pair with it, and that was a common enough pattern that with G and H, your two other functions, you wanted to name that or use that, you could spell that pattern, and then the quote unquote argument or operand that modifier train takes would then form the final.
And it's too simple example because you could there's an easier way to spell this, but just to be able to imagine how this works. Imagine if we had the fork reduce equals right tech. Okay, now because of the right tech, it could be simpler, but that's for illustration purposes. So now this fork, if you give it a maximum operand, because it's a monadic operator, then it indicates all the maxima. If you give it a minimum function as operand, then it indicates all the minima. Right? And if you give it a left tech, then it indicates all the ones that are equal to the first element.
Yeah, that's a good way of explaining it or visualizing it. Interesting. So you have clearly a whole set of these.
Is every combination represented?
No. The arrays, and if you only use arrays and functions, yes, and some of them are quite silly. For example, the first one you see is XYZ when they're all arrays, and they just returns the middle time as a constant, and there's no point to doing that, but
Sure there is. What are you talking about? Don't speak down about this language like this.
And use them for documentation, X and Z.
No, but if you want some side effects happening of those outer functions, and you want to make sure they're happening in a specific order, and then returning the middle value.
But in the first case, they're not even functions.
No, the expressions.
Oh, okay. Yeah.
So you could have any expression, and you want the side effect of the expression without disturbing the fact that you're returning eventually another value. And that the middle expression may depend on things that have been side effected into being by the outer ones. So certainly useful.
yeah. For the adverse, if you use adverse or conjunctions, not all of them are defined. I have more than Jay has because some of them suffer from the same problem of like they would parse as function application or conjunction application, etc. So we have some more, but I don't have all of them because well, there are a lot. And I tried to make some of them. I can't find a way to make them make sense, so I just don't have them. But if you see that there's ones that's missing, I can add it.
Or send me a list of all the ones that's. I mean, I could probably do this, generate them myself. We'll come up with something. We've gone this far, might as well take it to its bitter conclusion.
Yeah, well, there are also some that have that could have two interpretations, right? So there's one where it's an adverb and you have you have array conjunction adverb. And so there's kind of two empty slots, like the array is supposed to bind to the conjunction. That makes sense. But then you have the right operand of the conjunction and the left argument of dyadic operator and the left operand of the monadic operator, depending on what your preferred terminology is. So you could do it in either order. You could pass that operand into the monadic operator first or the dyadic one. And so you've chosen the monadic operator. Is there like a system for that, or is it just case by case? Or
I think I just took them from Jay, and I trusted that was a better choice.
All right, yeah.
You can't trust.
I've got no idea how the J ones work, so.
Well, and I know Henry spent a lot of time thinking about which ones he would put in, and there were a few that were suggested that he categorically denied.
Yeah. He
said, no, that's just not the right way to think about it. And I don't know all his reasons, but I know he did. There was a lot of discussions when the modifier trains came in about which ones would go in, and there was a couple suggested that he just said, no, that doesn't make sense to the way I see this working, and so they've never been put in. So it was definitely thought about.
I wouldn't blanket trust Jay when it comes to trains. Just look at the hook disaster.
Well,
They were just they were experimenting. They they were the first ones. Adam, you gotta take it easy. Take it easy on Jay, okay? Roger admits, it was a mistake.
Yeah, but that's why you shouldn't blanket copy it.
Were the modifier trains designed before or after that was realized to be a mistake? I don't know.
Oh yeah, that's a good point.
Yeah, and it could be that the design of the modifier trains is trying to mitigate some of the issues coming up because of what the two train is in J, and therefore you don't want that when you are doing modifier trains.
that's a really good point, because I'm not sure how developed modifier trains were when the hook was put into place. So depending on which one sort of showed up or whether they showed up at the same time, there might have been mitigation involved.
Surely the hook is way before. I mean, the two train being a hook predates J, right?
But yeah, the question is not when the hook was added, but when Roger decided the hook was not the thing that should have been added, which hasn't been corrected in J, of course, because that would break like all of anything written in J.
Bring some code.
Pretty much everything.
So yeah, I have the short version history on APL Wiki, and I don't see modifier trains being introduced the first time on there. So I don't know when that happened.
Yeah, I'm only going by when they were taken out, which I think was around 2004.
But even it doesn't really matter, right? Let's assume that modifier trains were originally designed before the realization that the hook was a mistake, that the two train being a hook was a mistake. Still, the modifier trains would have been designed to work as best possible, or should have been designed to work best possible with the two train being a hook.
Yeah, so it's more a question of how much you should distrust rather than whether you should distrust.
Right. And if the modifier trains were designed after the hook and was realized to be a mistake, then they would be designed ideally to try to mitigate some of that. Either way, it doesn't seem appropriate for an APL that doesn't have hook two trains, whether it's designed for or designed against, but you can disregard it altogether. So you should really rethink from scratch and make sure you get the right thing. But I'm with Marshall here that when there's different ways of doing it, maybe, I mean, there certainly weren't a lot of thinking, but maybe in that case, it's best not to have it because it's ambiguous.
Well,
So,
I have no particular suggestion for this. I don't have any idea what I would do.
yeah, modifier trains in BQN when?
Never. I would take out user-defined modifiers before I did that.
So I guess an interesting question, at least for me, is to get your thoughts, Madeline, on how, because one of the thoughts in the back of my head is that I think it's Henry Rich's book, I'm not sure if he's the first one to refer to them, but he refers to trains as invisible modifiers, and in that they are these, adverby conjunction-like things, but, the patterns, the trains, whether they're function trains or modifier trains, they're invisible. You have made trains not invisible. And I think actually this is the first language, array language, that has made the invisible modifiers no longer invisible. How do you find, because I will say that there is some of the appeal of the modifier trains in J is that that they are invisible. Like it's already, we can have a discussion of the practical, is it a practical thing to use or scatter into your code? And then it probably only becomes worse by it being invisible. So does the fact that they're not invisible, like they're explicit, and you even use the same syntax with the prefix and suffix underscores, like how does that affect the readability of these things, do you find, or have you not used them enough, because you said you use them sparingly?
Well, first of all, CAP had added explicit train syntax before me, at least for some trains, but I think that the explicit syntax actually makes them clearer, because if you have longer expressions in a train, it's easier to tell when one ends and the other one begins, right? So I think that my trains are clearer than dialogues. They are more verbose in simple cases, but the verbosity is an advantage in more complex cases, I think.
Yeah, I could totally see that. So Cap technically added explicit syntax for The fork, is that the same thing? I'm trying to think. Is that the same thing as making, because they technically just got rid of the three train, and then it was the fork. Is that the same thing as adding syntax for forks in general? Or it's not forks, it's for trains.
I'm just going by Henry's book, J for C Programmers. I'm pretty sure when he talks about invisible modifiers, he's just talking specifically about three trains. I don't think he's talking about modifier trains at that point because they didn't exist.
Well, so to be clear, there were the like adverb trains, and you could do a partial application of a conjunction. So there were some very limited forms, but I mean I don't know if the book even covered those.
Even dialog has that.
Well, it has things like each in it. It explains that, but it doesn't. It's almost like those are just sort of leftover details that are really useful rather than
Yeah.
something that's a construct of the language, which when you put modifier trains back in, suddenly you see the full power of them again, and whether or not they're super useful, I guess, is yet to be determined.
Yeah, I guess right now I'm thinking, what's the delineation between train programming and like fork programming? They're the same thing in BQN and Dialog APL, but in CAP, Elias separated the fork from trains in my head. And so he added explicit syntax for forks, and then train programming is really only in two trains, which is just unary function composition. You can have a fork or a phi combinator or a phi1 combinator, but that's no longer quote unquote train programming in my head because there's explicit syntax for it.
Yeah, so that's actually kind of the same thing as what that only functions of one argument is pretty similar to what Jay restricted their modifier trains down to, because it's just chaining adverbs together and being able to fill in one operand of a conjunction.
Interesting. And then yeah, in tinyapl, you're still doing quote unquote train programming. Even in my head, this is just kind of my mental model for it. It seems like you're still doing train programming. It's now just that though to spell a train requires explicit syntax, which is why like I'm kind of like I feel like I just said the same thing twice, but then came to two different conclusions for tinyapl and cap. In cap, they added explicit syntax for forks, which no longer makes it a train. Like, or is it still a train? And I think it's because the documentation says there's only support for two trains, and the fork is now explicit syntax. Whereas in tinyapl, it's there support for trains. There's just explicit syntax with the crescents and then the diamonds to separate. Adam's got his hand up. We'll let him correct what I've said.
No, I can't correct you because it's a judgment call. It's a nomenclature call, but I would suggest that we say that trains are just sequences of things, like whether it's functions normally, or it could be these adverb conjunctions or other things like that. That maybe means that even the strand is a type of train. Maybe even means that a normal expression is a type of train. Whereas forks is the flow pattern. It's the pattern of giving arguments to the to two functions and then passing the results into a third function. If we distinguish like that in a way that's not meaningful to distinguish in BQN and J and APL because trains are forks, three trains are forks, and then it makes it a bit easier to speak about it. Then we can say that cap certainly has forks and tinyapl certainly has forks. Cap also has trains, but they are just atops. And tinyapl does not have trains. So just try it. Any sequence of two adjacent functions isolated from anything else is an error immediately. Does that make sense to give us some language to speak with?
Yeah, so you could say trains are a syntactic feature and forks are a semantic feature is the
Yes,
kind of
yes,
one sentence
exactly.
condensation.
Right. But I mean, there's a little bit of weakness in what I'm saying in that there's no good distinction then between a normal expression and a train. And of course, we always end up with I. And in I, there indeed is no distinction between a normal expression and the forky train, right? One and the same. But I think it's good enough for our purpose, where we just assume that if it's something that immediately evaluates to a value, then we don't call it a train, though we could. And that gets rid of both strands and normal expression.
Yeah, in BQN, the rule is just that a train is an expression that results in a function. So
Yeah.
many of these expressions are going to be one trains, but you can say clearly that 1 + 1 is not a train because it results in an array.
Yeah.
Whereas, plus minus times is an array, is a train because it results in a function.
But 1 + 1 in I does result in a function.
Yes, because everything in I
Like
is a function.
the two function. So
And just to clarify, I is a language that Marshall developed. It was
Designed by me,
designed by Marshall.
that I don't mention in my introductions, I suppose.
Marshall, why did you not say I designed it?
I probably did say I in my introductions, but people thought it was referring to me.
I think Madeline would like to add something here.
Yeah, I think another important thing that trains do is longer trains, right? As far as I know, every language with trains, you can do a 5 train or a 6 train or a 94 train. That's the thing that Apple can do. I think its train-like syntax is more like trains because it can do that. You can do longer trains.
I can't do 94 part trains, 94 trains, invalid.
Well, I mean, it depends. So it's always going to be split up into 3 trains, but it's not any different than the way APL does it, really.
But 94 doesn't have to be an odd number.
Oh, yeah. No, it can only do 93 or 95. Sorry.
Oh yeah, no, you're right.
Yeah, so it doesn't have 94 trains.
Yeah.
You could extend I with even length trains, give them some meaning, make them a hook or something.
Yeah, but then it's only ever the very first token you write that can be the even one, and everything else is decomposed into 3 trains.
But so anyway, to go back to what Madeline was saying, that other than I, we allow any length trains in any of these languages. Although you could argue that something like cap doesn't allow any other.
Well,
hold on.
Well, it doesn't allow any other fork types, but its trains are definitely.
Yeah, trains can be any length, but they're different. I wanted to say that. Okay, I wanted to say that caps, forky replacement for explicit fork replacement for trains, can actually only be length 3. There's no, because it's a syntactic construct. There is no thing as a 4 train of in the forky sense, or 5 in cap, because all you end up doing is the syntax dictates what's one tine of the outer fork. You can have a fork though where some of the tines are forks themselves, but they're still just 3, and the special syntax for 3. And cap could add a special syntax for a combination of 4 things, whatever the meaning of that would be. But it would still be it's explicitly only that.
Well, I mean, so the syntax is more designed to bring out that feature, to make that feature clear. But it's also true in APL and BQN that there's only a 2 train and a 3 train.
Yeah.
And it resolves the precedence. Like it doesn't matter which direction it builds an odd train from, but it chooses to do it from the right. So that is like part of the language design. I mean, it's a lot like in an imperative language, you have, if A do this, else if B do this, else if C do this. There's not actually a multiple if construct. It's instead chosen that this if else thing is right associative, so it looks like one, but it's built out of fixed length components.
It goes, hold on, but the if statement goes from the left.
No, I don't know what you would mean from the left, but like if and else are right associative.
The first thing that.
Yeah, if you have nested ternary, is you evaluate the left one first. And
yes.
Yeah, so the parsing is right associative. The evaluation starts from the left, but.
Okay. I was thinking of an else if, but in tinyapl, yeah, we're right back to, well, you can have any length train, but really they just end up being forks. And so forks or forks or forks until you have in the top. Its question is just, is it explicit or not? It's almost like if you took JAPL BQN and you added some color to the back to the paper it's written on. It's what tinyapl has is just background framework slots.
Well, no, not only that, because the separators are explicit. So
yeah, so it's every tine is parenthesized implicitly.
I mean, it's explicit. It's just a different explicit.
Yeah, okay, but there's no. It's not a parenthesis, but it could have been. Madeline could have chosen a syntax where instead of using diamonds, it would be parenthesis of some, the outermost layer of parentheses inside the special marker of context switch is what creates the tines, and then you could have a special symbol saying, whenever you have a right paren followed by a left paren, right, where one tine ends and the next one begins adjacently, you could replace that with a close paren opening paren character, a single character instead of two. And not only that, you could omit the first opening paren and the last closing paren because they're obvious. And now you're right. And if they then design your close paren open paren character to be a diamond, then it's the same thing. So it's really just a visual difference.
Well, so like yeah, there is an explicit train syntax that would have that correspondence to tiny apples. However, APL and BQN use an extension of that syntax, which doesn't require you to have the prints. So I mean, it's a different like then it matters that that modifiers have higher precedence than functions. So I mean that there are different syntax considerations when you have that sort of implicit syntax, I think.
Well, you need to have the separation for some syntactic constructs that I'm not even sure any of them are allowed. Like if you allowed, for example, an array conjunction array train, which I don't think is allowed, supported. It is actually. But it doesn't do anything. Huh, okay. I was about to say that array conjunction array would be ambiguous with, say, array conjunction array, right? If you understand what I mean. But it just happens to be also defined to be exactly that. So there's no actual problem there. But potentially you could have some kind of construct where the outside of train syntax and inside explicit train syntax would mean two different things. I don't know if that actually ever is the case.
Yeah, I mean, so I think this
Yeah.
not only having the explicit indication outside, but also the explicit separators inside is doing something that just the outside indication alone wouldn't. I mean, it separates the semantics of trains further from the syntax so that you really can you don't have these syntactic considerations that are bleeding into what sort of trains you can write. It's only based on, here's my sequence of things, make a train out of them, which still has some like that's not necessarily a natural or it's not always a perfectly well-defined thing to do. So the language still has to make choices with that, but they're no longer tied to having to disambiguate it from the normal expression syntax.
So, Madeline, aside from getting us into a really deep discussion into the syntax and the semantics of trains and forks and such things, which I think if people do follow along, they'll actually learn where some of the complications are. What else do you want to do with this language as you're developing it? You're developing it very quickly. You're adding all these extra things. Where do you want to take it?
Well, my main goal is to make like an experimentation playground. After I'm done with like all of the primitives that I have planned, so 1.0, I want people to suggest new primitives, want people to suggest new stuff to do with the language, and I want to add it and have more people try it out and find if it's actually a good primitive or not. I also kind of want to make it faster because it's horribly slow with doing something, but I would have to do big changes in the code base, and maybe that's better left for a completely new version done from scratch, which I also have planned. But yeah, the main goal is to experiment with primitives.
And I will say that there are a massive number. Like it's called Tiny Apple, but maybe that's a joke because I'm pretty sure you've got more primitives than. Like I was checking to see, oh, did you have this or that? And I was like, you've got on top of maximum and minimum, you've got maximal and minimal. I'm not actually sure what those do, but there's a ton of. Maybe you can tell us what the maximal and minimal do. But it looks like there's like every glyph you've ever seen in all the APLs combined, which actually I there's a whole other discussion of, how many glyphs is too many. I don't think that there is enough, keep on adding them. When you learn some of these ideogram languages like Chinese, you learn like thousands and thousands of these. I think if you're going to work with a language, you can actually learn them pretty quickly. Anyways, over to you on, maximal and minimal. And maybe if you want, you can tell us a couple of your favorites that you've put in that are, not found in some of the other array languages.
Yeah, so it's called tiny, not because like it's tiny for the user. It's called tiny because each primitive is implemented in not a lot of code. Like I have 130 primitives, I think, and the whole code base is about 4,000 lines of code, so it's really small, I think. That's why it's called tiny. The difference between the minimum and minimal, and the same goes for maximum and maximal, is that minimum is like pervasive. So, or scalar function, or call it whatever. So if you do like two lists and you do a minimum of them, it does the minimum of each pair of elements of the list. Minimal instead takes the whole list and compares them like you do if you do grade on the two lists, and then returns the smaller list as a whole. So it doesn't combine the two lists in any way, it just chooses one or the other. The same goes for the total array ordering comparisons, which are proceeds or identical, identical and not identical, succeeds and succeeds or identical, which are the total array ordering correspondence to like less and less or equal, etc. And identical and not identical appear in every APL. They call it match and not match, or natch or whatever. I call them identical, not identical, because they're better names, I think. And they fit better with proceeds, because otherwise the less or equal equivalent would be called proceeds or match. I don't really like. So identical is better, I think. But yeah, so proceeds, which is like a left pointing triangle, is the natural extension to match. It's the you compare it to arrays as a whole, not for each element, and then you return which one is whether they are the first one is lower than the other or not. It's not per se pervasive. It just compares the two arrays. And I really like those primitives. I use them a lot. I also like the ternary syntax, which I just introduced a few days ago. And it's kind of like ternary in JavaScript or whatever. I use a quad question mark and a quad colon to do that syntax, because question mark and colon obviously have different meanings in APL and in tinyapl. But I really like that. I use it a lot. And other than that, I don't think I have a favorite primitive yet. I haven't used language enough, probably. But I really like the capability that you can do like graphical output in the JavaScript interpreter. I added the support for plots, for images, for GIFs, for audio. Yeah, so they obviously stolen from Viva, but I really like the graphic capabilities. Yeah, it's something I use a lot. Recently, I've been when I need to do like data visualization or whatever, I do it in tinyapl. Both to figure out what the problems are, what primitives are missing, etc. But also because it's really fun. I think it's a fun experience.
So now that you've spoken about the total array ordering, I'm a bit wondering why you have the ordering that you have. You want to speak about it a bit? That's another one of the top level info pages, the ordering page.
Yeah, I will have to look at it too, because I don't remember. I very rarely use mixed type ordering. I think characters come after numbers, and there are actually I don't remember. I never use it. Almost never. The When I compare two arrays, total array ordering, they're either all the same type usually, or they're like scalars, but they are lambdas or wraps, as I call them, so first class functions. Because you can't do equal on them, because you can't meaningfully compare the code of two functions. And I am considering doing like reference equality, and I think about that, but for now you just can't. It's always false. But what you can do is order them, because everything is order, right? And ordering wraps, it goes based on the representation. And representation of defense is not useful, because it's always like open brace, dot, 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 close brace, because I don't store the code inside it as a string. I probably will eventually, but I don't right now. But for primitives, if you want to compare like a primitive, like let's say if you're writing in the standard library, there's a function called bitwise, and an operator, an adverb called bitwise. And what it does, it's the same as similar to like the bitwise primitive operator in cap. So it takes like end and turns it to bitwise end. And the way it's implemented in standard library is as it wraps the operand, and then it does like a grade on it, I think, or a proceeds, I don't remember. Anyways, it checks that they're the same using proceeds and succeeds. If they're both proceeds and equal and succeeds and equal, it means they're equal. I use this mostly for that. But yeah, the actual ordering is not thought very deeply about.
So for example, it means that a short name that begins with a letter later in the alphabet sorts before a longer name that begins with an earlier alphabet, like ZZ or ZZ, if you're so inclined, sorts before ABC.
Yeah, that's because the way it's implemented in Haskell is just the default or ordering instance. I think does that because arrays are defined as shape and then content, so it compares shape before contents. I don't think I decided to do that. It just came to be. I never had any problems with that. Yeah, maybe it makes more sense to compare the contents first and the shape, or maybe rank then contents then shape. Yeah, I just didn't think about that yet. It's nothing is settled because 1.0 isn't released already, so I can change everything with no issues. And some things I just didn't think about yet, and ordering is one of them.
How many was it? Was it years that Dialogue spent figuring out what you wanted to do?
It was a while. You might want to look at the paper Tau Axioms by Roger Huey and Jay Fode and myself. Mention us in that order, but it was just for the subject. It was funny that it didn't matter how we ordered by first name or by last name.
All right, the last and most important question we should ask is, and I was messing around with my keyboard and I figured it out, and I accidentally typed it, but then I couldn't figure it out because of the proliferation of symbols. You have mapped more than two glyphs to a key. And at least on the web editor, it's the same as it is for Dialog, APL, and CAP. It's the backtick. But how do you access like the third and what looks like potentially like fourth, fifth, and sixth symbols on some of the keys? Because you typically only are able to get access to two. What's the trick? And I know everyone always asks, how do you type it, as a joke on YouTube? And now it's ironic that I'm actually asking, how do you type it? But the people need to know.
Yeah, so there's six symbols, at most six symbols on each key in the image you can see on the keyboard. The first column is just the normal keys you get. So the lowest left is just pressing the key, and then upper left is shift plus the key. And then there is a middle column, which is what happens when you press the backtick once. So, like I'm looking at the A key. So, no, that's a bad example.
Take the R key as an example.
Yeah, I'm looking at the R key. So if I press backtick R, I get the row symbol. If I press backtick shift R, so the upper middle, I get the square root. And then if I press backtick twice, I get access to the last column. So backtick R, lowercase r, gets the row underbar. And then backtick shift R gets the real part symbol. So which is the upper right symbol. So each column is how many times you press backtick. So zeroth column is 0 times, first column 1 time, and second column 2 times. And then the rows, so the bottom row is no shift, and the top row is yes shift.
But that means you can't actually do a shifting keyboard for this. You can only do a prefix keyboard because you can't. I mean, if you press your shift key hard enough, it will break. But it's not gonna be double shifted like that. Maybe if you hold caps lock and shift.
Yeah, Control and Alt maybe.
Yeah, that conflates with the right side alt on some systems, some places.
Well, I implore the listener to go and, if not take this for a spin, at least go and check it out, because it is pretty wild how many glyphs, and it makes me curious. I want to now go, because I haven't spent any time, or at least in anger, used Tiny APL, and now I'm staring at a bunch of symbols, and I want to go, like I can see that there's the symbol that I discovered thanks to Adam for width, but I'm guessing that it's not width and that you've done something different with it. But yeah, it makes me curious to go and check out what all these different symbols do. I guess we'll make sure that we put a link in the show notes for not just all the documentation links, but also the editor that they can go try it out. Is this something that people can download onto their local machines and use it? Or is the editor online the main way people should check it out?
Well, the online is definitely the main way because it's much more refined. There is also a WebAssembly standalone executable, so you can download like Wasm Time and run it with that. but it doesn't have like input, so you have to copy paste the glyphs or use an external layout for that. I plan to eventually add those, but I'm not good at like terminal interface programming, so we have to learn more about that for sure. But yeah, for now, the best way is definitely the web interpreter.
Well, go ahead, Adam.
Sorry, I wanted to just respond to what you're saying about you want to go exploring the glyphs. We haven't spoken about the Omnibar at all, and tinyapl on Omnibar when.
When probably 1.0, I think. I have a branch where it's already implemented. It's not public, but because I keep changing stuff, I don't think it's just useful to keep changing the documentation on Omnibar. So
Maybe you should tell the listener what Omnibar is.
oh yeah, Omnibar is another project of mine that is basically a collection of all the glyphs in a lot of EPL dialects and what they mean, both primitives and syntax. So like you can see, there's a filter where you can write the name of a primitive or the symbol of a primitive, yeah, the glyph of a primitive, or you can choose what dialects you want to see. And yeah, there's like you can see all the primitives and all the syntax. So like for example, the first entry is plus, so the glyph plus, and you can see that it does identity or conjugate or addition or join strings in APL 64 apparently. I didn't remember that. Yeah, but there's a lot of symbols and what they do, and at the end there's syntax, so below all the primitives, and they're color coded, so you can tell what type each things are. So like there's yellow for monads and orange for dyads, etc. It's useful to have like a list of all the primitives that every APL has, and that's the first reason why I made this. Originally, it was much more glyph oriented. There was like the name of the glyph, and yeah, but it came to be yeah, a language bar in the sense that it's like a list of all the primitives that are available, and yeah, that's why you use it. It's called omnibar. It's called that because it's a list of all the primitives in every language, or a lot of languages at least.
Yeah, I had seen this before.
Yeah, we've brought it up on the Arraycast, and maybe as an announcement.
Yeah.
I think at some point a long time ago, and it is a very nice website. And yeah, you can see stuff that only exists in certain APLs. Like NARS 2000 has a bunch of unique stuff, and I just discovered that cap has a bitwise function, which I think if it does the same thing,
That's somewhat new.
yeah, I was going to say Weewa has a bits one, so if it does the same thing, then maybe cap borrowed that from Weewa, or maybe Weewa borrowed it from cap.
No, bits in Viva is like base to the encode, and bitwise in cap is an operator. You can do like AND bitwise, and does bitwise AND of two numbers, or not equal bitwise, and it does bitwise XOR.
I see. So it's two different things.
Yeah.
Well, a super, useful resource, clearly, and obviously a lot of work, because you've gone through, it looks like every single APL under the sun, to be honest. I'm sure you missed a couple, but looks to be like a double digit, at least 10 or 20 of these. So yeah, we will make sure. I'm not sure, you said you were going to publish something, but this already is online, correct? Or what was it that you were gonna modify?
Oh, it doesn't have the tinyapl glyphs yet.
Oh, I see. Yes. That is an oversight considering it's it's your APL.
Did she know about tinyapl? I guess not at the time of writing. She didn't.
I think the latest update was after tinyapl. I think all of it actually was after tinyapl, but I didn't have a parser yet, I think, when I did Omnibar, so it wasn't really didn't really make sense to include them because it was like an idea, so no point in having them. Now maybe it makes sense, but I'm still changing all the stuff, so I don't know, not yet. Just in a while I will add them.
Also, the table will kind of explode once it gets 10 apples. I guess Jay doesn't have to be ashamed of its large vocabulary anymore.
Oh, we never were, Adam. We never
Yeah.
were.
Always space for another dot or colon.
Primitive body acceptance.
Whatever.
Oh, yeah.
That's right.
So I have to come up with a glyph for everything I want. The J can just add a colon or add a dot or whatever. They have a symbol, right? It's cheating, I think.
Yeah, but there's so many characters in Unicode.
Yeah, but they never have the ones they want, so I have to always compromise. You know?
It's an interesting tangent. Maybe we shouldn't go on now, but Unicode is kind of a blessing and a curse. In one way, it's a blessing because now it's obvious how you should store all these primitive symbols and so on. But it's also a curse in that it's locked down which symbols exist. It's basically impossible to get a new symbol into Unicode if it hasn't already seen extensive use. You'll just be referred to the private use area. And compared to getting the APL glyphs into Unicode, it's very easy. They just did it without anybody even asking for it. And so we have, for example, the greater than diasis is in Unicode, but there's no less than diasis, and probably impossible to ever get it there. And we have to do weird tricks that I see even tinyapl does, of using what is it, Cherokee syllabics and things like that approximate the shape we want, and then the font render them as what you actually want. But the situation is already bad enough if you're not using the right font out there in the world. If you don't do that for tinyapl, then it becomes very hard to read.
Yeah, definitely. I haven't put much thought into what people see if they don't have the font. Surely it's not great, but most of the things are correct. I think the only ones that I cheat a lot are boxed, which is like if it's a kind of useless separator, but I like it anyways. It's basically it does enclose a top and then the function, and that uses like a Cherokee letter, which is not actually an enclosed with two dots above. It's enclosed with like one dot above and one dot to the left, and my font makes it two dots above. But apart from that, everything is mostly correct to Unicode.
Mostly correct should be the definition of Unicode, I think.
All right. Well, as we mentioned before, links for all of this stuff will be in the description. I implore you to go check this out because it definitely is an immense amount of work, even if it only is 4,000 lines of code. It's some really cool stuff. I will throw it over to Bob, who will let you know how you can reach us.
You can reach us at contact@arraycast.com, and questions and comments and all that sort of thing will be taken in and distributed and sometimes answered, but always read. And also a shout out to our transcribers who will put this into written form for those of us who ingest the podcast in that way. I will point out that podcasts are not meant to be read, but if you choose to, at least understand you're not reading it in the way that we intended it. So if there's complaints about how it reads, you might want to listen to the podcast.
And yeah, thank you so much, Madeline, for coming on. This has been extremely interesting and thought provocative. I'm gonna have to go spend more time going through all the different glyphs, and I'm sure that there's a couple in here that I don't know that I want, but as soon as I see it, I will be like, oh my goodness, every other APL needs this. So thanks so much for coming on, and hopefully you'll get some feedback and some more folks looking at this after this airs.
Yeah, maybe after this podcast, I will go from one user to two users, and that will be great.
We all can hope. And with that, we will say happy array programming.
Happy array programming.